What's going on, everybody? Welcome to the image processing with Python. So in the previous video, we have seen some image enhancement techniques using histogram equalization and histogram stretching. We have also seen how to make histogram. Now let's move forward. So in this tutorial, I will tell you about what is the difference between convolution and correlation. We will also apply mean, median and mode filter here. So let's get started. Now let's say our kernel is 3 cross 3 here. We have 5 cross 5 image where gray values are between 0 to 7. Now suppose we want to apply this filter in the image. So for that, we'll select one window of the same size of the kernel, a red box which you can see here. Now we'll multiply each component from the filter piece by piece with this window. We'll add all that value, means we'll add total 9 values, and we'll replace that value with this middle pixel. And that's why we always use odd size filter, because 4 cross 4 and 6 cross 6 kernel don't have middle pixel. So this whole process of adding and replacing is called as correlation. But for convolution, we rotate the matrix 180 degree. So I put the image with normal kernel and 180 degree rotated kernel, so observe it carefully. Now this kernel here is symmetrical. It doesn't matter if you rotate 180 degree or not, it will be same. Hence the correlation and the convolution is same here. Now the size of the image will also reduce due to convolution, because 3 cross 3 window can't move forward more in this right direction because it at least need 9 elements. And you can also observe the output image with reduced size here in the right side. So with 3 cross 3 kernel, one row and one column is reduced from the both side of the image. In 5 cross 5, 2 rows and 2 columns will be reduced. So in general, the rows in the output image will be image rows, which is 5 here, minus kernel rows, which is 3 here, plus 1. So it will be 3. That's why here in output we have got 3 cross 3 image. For more details, check out the video in Matlab wherein details explanation is given. Now we'll use the same filter for mean, median and mode filter. So in the mean, as I said earlier, we'll sum this all value and divide it by total number. So here it is 9 and replace in the middle. That's why we have here divided by 9 in kernel itself for finding the mean. For 5 cross 5 kernel, we will divide with 25. In the median and the mode, we'll use empty kernel. We'll apply in the image, we'll take median and mode values from the value under this window and replace with this middle pixel. Now let's actually implement it in code. Now let's import the important library first. Here I am using a flower image which I have been using in this series. So due to high resolution, we need to resize this image. So I'm resizing it 800 to 600 pixels. And also we need to define a filter. So here I'm defining 3 cross 3 filter. And remember, if you divide an Numpy array with 9, all the elements will be divided by 9. That's what we need. And we'll also observe the output with 5 cross 5 filter. Here I'm also finding the shape of the filter and the flower, which will be used later to generalize the code. And here we also need to convert our RGB image to a binary image, because we want to convert 3 channel to 1 channel. So if you want to apply a filter in 3 channel, you need to split all three channel. You have to apply it and you have to merge it. We'll do it in later tutorial, but as of now, let's convert it into a binary. Now let's visualize the image. So here I need to write wait key 0. Now let's hit the run button. So here we go. As you can see here, our image is converted into a binary image. So previously I have told you that due to convolution, the size of the image in the output will be reduced. But if we want to keep the same size, we need to do a padding. So we can do a 0 padding, means we add rows and columns of the value 0 in the input image. So the total 2 rows and 2 columns can be added both sides if we are applying 5 cross 5 filter to keep the dimension same as input. In general, we can say that the size of the input image with padding is the size of the input image plus the size of kernel minus 1. So the size of the input image is 7 cross 7 plus 5 cross 5 will be 12 cross 12 minus 1 will be 11 cross 11, which you can observe here in the image. So we'll add 2 rows and 2 columns both sides of this image. And the other way is to repeat instead zero padding. So we can repeat this first and second row here and the first and second column here. Now let's implement zero padding in code. So as I told you, the formula of the input image with zero padding is image size plus kernel size minus 1. So let's define it here. So say row is equal to image row plus kernel row minus 1, and for column we'll write s1 plus 1 minus 1. Okay, now let's define a zero value arrays. So let's say z is equal to np dot zeros and write here r and c. So for zero padding, we add zero value rows and column both sides of the original image, right? So for 5 cross 5 kernel, we have added 2 column and 2 row here in both sides. Now think a different way. Suppose we have zero value array, means all these values are 0 at first. And for zero padding, we need to add here actual image pixels. So for 5 cross 5 kernel, our pixel value will start from this third pixel and second position in the language of Python. If the kernel was 3 cross 3, then we could have start from the second pixel and the first position in the language of Python. So we can make it in general form like this. We can say that kernel size minus 1 divided by 2 means our pixel value will start from 5 minus 1 divided by 2. So 2, this position. Let's implement the zero padding through code. So our image is 2D image, right? So we'll need 2 for loop, one for row and one for column. So let's write here for I in range, let's write it in general form, so it's 0, and for column right here s1, and we are changing the value in z array, so write z I plus np dot integer, and let's apply the formula which I've told you before, 0 minus 1 divided by 2, and let's also keep it in round bracket. Same for column, so let's just copy paste it. The only change is instead I will write say, and instead 0 I will write 1, and we'll change this value with flower gray I j. Now let's print the j so you can have a clear idea about it. So you can see that our input image is successfully zero padded. So now let's come to the main part. So we need to extract the windows from the padded image. So suppose this is our padded image. Now what we'll do, we'll extract this window. So in this case it is 5 cross 5. So let's just select a 5 cross 5 window. We'll apply this filter here. We'll sum all the values and we'll replace it with this value, right? And second time we'll apply this filter here, same here and here, and we'll replace with this and this value. So now let's actually implement it through code. So for again for row and column we'll use 2 for loop, and for j in range s1, right? Now we need to extract the window. So let's say z I, so at I is equal to 0 we need 0 to the value of the filter size I to I plus filter size, right? And same for j to j plus filter size. And let's say it k. Now define L is equal to np dot sum will do summation of this k window and our filter. Okay, and we'll replace this L with our image value, so which is foreground ij is equal to L. That's it. Now let's visualize it. So cv2 dot I am show, right, final flower gray, and let's just cut here and paste it right here. Let's see. So as you can see here, this is the original image and this is the blurred image after applying a mean filter. Now let's apply a 5x5 filter instead 3x3. So let me just comment it and uncomment it. As you can see here, we have got more blur than previous. So as you increase the kernel size, the blur value will be increased too. So for median filter, we'll need an empty kernel. So if you want to apply a 3x3 kernel in the image, we'll need a 3x3 empty kernel. So instead empty, let's define it this way and let's comment it. The best application of median filter is to remove a paper salt noise. So I have a salt image. So let's apply it in our image. So instead here multiplying and summing, right here a median, and we'll need only a window size from our image. So let's run the code. Here we go. So as you can see here, this is our image with salt noise, and this is after applying a median filter. So as you can see here, noise can be removed with median filter. Now for applying a mode filter, we'll do a same procedure, but one problem is that Numpy array don't have mode method, so we need to import additional library. So from Scipy import stats. Okay, and let's here define stats mode. So this argument will return two array and the mode value will be first in a first array. So here we'll write L in first array the first value. Okay, and now let's test this filter in paper noise and let's hit the run button. Okay, there is some mistake. Let's write here one more argument, which is axis is equal to none, and let's again hit the run button. So the reason behind writing none is that we don't need a mode value from any column or any row. We need the value from that whole window size. Here we go. So this is the paper noise and this is the output from mode filter which we have got. So as you can see here, in paper noise, the mode filter doesn't give a good output. Now let's again test it in salt noise. So right here, salt instead paper. I'll provide a link in the description for all the input image which I have been using. So don't worry. So we have got a good output in this case. So as you can see here, all the salt noise is removed with mode filter. In the next video, we'll discuss about Otsu's thresholding method, which is most famous method for binarization. And again, if you are not comfortable with Python, we have uploaded a same video in Matlab platform also. So don't forget to check out. And if you have any inquiry, write it in comment section or mail us. We'll try our best to solve the problems. Thank you.